Okay, so section 2.4, a little bit on correlation. Okay, we're not going to do much with this in this class, but this video will pretty much tell you everything I want you to know. So we're in 2.4. Going to talk about correlation, scatter plots, which is a graph, and then linear correlation coefficient. It'll tell us how strong the correlation is. So I think you have an idea of correlation. It's just a relationship, really. Linear correlation is just going to be a straight line in the pattern. There's other correlations. For instance, here's exponential, which you may have seen with the COVID-19. It's been following an exponential model. So let's talk about correlation. Let's talk about positive correlation. Let's see, beers consumed and your blood alcohol content. Positive correlation just means the more beers, as beers consumed goes up, your blood alcohol level goes up. So if I was to graph this with beers and BAC, if it's linear correlation, it's going to look like that. The more beers you have, the higher your blood alcohol content. Okay, let's look at negative correlation. How about days on diet and your weight? Hopefully, the more days you're on a diet, your weight is going down. So here we would have days, here we would have weight, and we have a negative correlation. Notice here that the slope of this line is negative. And on the other one, it was positive. So a scatter plot, when we do one of these, and I'll just go up here with beers and blood alcohol content, you're going to get ordered pairs. Supposedly you have 6 beers. You're going to have a dot here, a point on the line or on a scatter plot. It doesn't have to be on the line. They'll be all over. Maybe this is 0.05. So you'll have an ordered pair of 6.05. That's your X, that's your Y value. So here's a scatter plot. So each of these points, for instance, I don't know, I'm guessing that point there, the waist circumference in centimeters was 100 centimeters, and the arm circumference was 35 centimeters. Now, this is pretty strong correlation because if I was to fit a regression line, it would kind of go through there. It's the line of best fit, and all the dots are pretty much around the line. Okay, here's waist and pulse rate. So here's a weight of 75 kilograms. So that point would be 75 kilograms and a pulse rate of 70 beats per minute. This is rather weak correlation because where's my line of best fit? Even if it's here, notice the dots, all the points are far from the line. So this would be weak correlation. I have a couple of examples here. The linear correlation coefficient R, that tells us if we're weak or if we're strong or in between. So it's always between -1 and 1. So if it's negative, so suppose R is -0.5, you have negative correlation. And if R is positive, say R equals 0.70, you'd have a positive correlation. This would be stronger than that because that's closer to 1 than that this is to -1. Okay, here's an Excel spreadsheet I did where this is shoe size and this height in inches. This is from a previous class we collected this data. Well, it's pretty strong correlation because it looks like the line of benefit is right in there. So I did this on Excel, and unfortunately, I have no idea. PowerPoint did not capture this picture for some reason, because it was supposed to put the line in there, and Excel gives me two things. It gives me the equation of this line, and it gives me an R² value. So I want to look at what the line tells us, and then I want to look at R value, because I have R² right now. Okay, first of all, let's just look at R. If I want R, little r in the book, I take the square root of R². So the square root of 0.7962 will be larger than this. In fact, it's 0.89. That's close to 1. So this is strong correlation. So we have strong positive correlation. Okay, now I want to look at the slope of the line. That's the next big thing. Okay, my slope, quick review of slope. Everyone probably thinks, oh, it's rise over run. Well, it's also the rate of change. And that's what I'm concerned with. So I really want to look at the units on the y-axis and on the x-axis. So this was shoe size. This was height in inches. So my slope is 1.8 inches per shoe size. What that tells me, and what I want you to know, is for every increase in shoe size, suppose you go from a size 8 to a size 9, the height increases (1.8 inches). That's my positive correlation. As shoe size increases, the height is increasing. Okay, I got one more example. Okay, this is age of professor. This is student evaluation. You filled them out, they go from 0 to 5. So if I look at this point here, it looks like 60, comma, like 2.4 maybe. So that professor was 60 years old. His average evaluation was 2.4. Again, Excel did not do what it should have done for me. Well, actually, PowerPoint, I shouldn't blame it on Excel. Excel was fine. But there's maybe the line of best fit. Notice that the data values, the ordered pairs, are not real close to the line. So this should be kind of weak correlation. Well, like before, I got this data. Here's my regression line, 0.022x plus 2.8. R squared was 0.16016. Therefore, R, the square root, is 0.40. So not close to 1. So weak correlation. Now the slope. 0.022 divided by the age was in years and the y-axis is student evaluation points. So I'll make that per year. So although it's weak correlation, we have a slope that says the evaluation points are increasing 0.02 points per year. And that's all I want you to know. How strong is it? For example, problems I like to do, play around with, is give you a scatter plot like this, and then ask you, estimate R. Well, if you gave me R equals 0.9, we know that's bad because this is weak correlation. So if you gave me an R equals 0.6 or something like that, you have an idea that it's not real strong. That's it.